In 2023, the super-powerful James Webb Space Telescope made a sensational discovery, and not just one. It detected 6 massive galaxies we didn't previously know about, and they're all incredibly large. One of them is estimated to contain around 100 billion stars, which is the same amount as in our Milky Way. However, this galaxy is increasing 20 times faster than ours and will soon reach the gargantuan size of several dozen Milky Ways. Can you imagine how extensive that is? I personally feel uneasy when I ponder the fact that by cosmic standards, our planet is incredibly tiny. It's especially uncomfortable to think that astronomers have already obtained an image of a planet that could hold several Jupiters. They've also managed to find a star that is several billion times larger than our Sun. But that's not all. In this video, I'll tell you which object is absolutely the most gigantic thing in space. When you look at the night sky, it seems almost two-dimensional from Earth, although nowadays even a child will tell you it's actually not. But it took astronomers thousands of years to figure out how to measure distance from Earth to the stars and create real three-dimensional maps showing the distribution of stars and galaxies in the universe. Now researchers can even calculate the size and mass of astoundingly distant celestial bodies, and when it comes to solar system objects, it's like a first-grade task for them. Over the past 50 years, many probes have been sent into space. When they fly past a planet, science can measure how its speed changes. It helps determine the planet's mass. To calculate its size, astronomers use observational data obtained from NASA telescopes and space missions. This implies that, for example, the size of the solar system's main giant can be measured almost down to the centimeter range. Thus, they found out that Jupiter's diameter is 142,584 kilometers, 11 times that of Earth. If the gas giant were the size of a basketball, our Earth would be the size of a grape. Moreover, Jupiter is 2.5 times as massive as all the other planets combined. Due to its large mass, this gas giant has a stronger gravitational field, which, according to many scientists, even helped form the solar system. If, for some inexplicable reason, Jupiter shrank, all the planets would just scatter across space. It's like when children spin around holding hands. If one of them opens their hand, the others will start falling and bumping into each other. But in our case, the solar system and Jupiter wouldn't end up just having some bruises and lesions. The planets would crash into one another, destroying everything in their path. In a nutshell, the gas giant is so massive that astronomers often refer to giant exoplanets with high surface temperatures as hot Jupiters. One of those planets is called WASP-12b. It is also a gas giant, but twice as large as Jupiter. Scientists began to call it the pitch-black exoplanet after the Hubble Space Telescope discovered that WASP-12b reflects only 6% of the light hitting its surface, making the planet look as black as fresh asphalt. But that's not the only oddity of this gloomy celestial object. While our Earth spends an entire year making a complete trip around the Sun, WASP-12b orbits its parent star in just 26 hours. That's because the planet is too close to its star. This proximity even changed its shape. The star's tidal forces distorted it from a ball into something like an egg. But soon, WASP-12b will no longer be included in the top of the most giant planets, because its parent star will eventually engulf it. Yet even with all this, the pitch-black exoplanet is not the main record holder. The most massive planet scientists have ever discovered is HD 100546b, and it's almost 7 times the size of Jupiter. Some would say it's undeservedly included in this list, because HD is not really a planet but a brown dwarf. But since it's difficult to consider them full-fledged stars, scientists decided we could put it on the list of the largest planets in the universe. Whereas the celestial bodies presented in this top compete in their size, some giant space objects can compete in the degree of their danger. The largest object in the solar system is certainly not Jupiter, but the Sun. It's 10 times the size of Jupiter and 109 times the size of our Earth, but such dimensions of our main star can play a mean trick on us. According to scientific calculations, the Sun keeps expanding throughout its entire lifetime. When it reaches its maximum size and becomes a red giant, its outer layers will begin to consume the planets within Mars's orbit, including our Earth. But the universe has many stars much larger than our Sun and therefore more dangerous. For example, VY Canis Majoris, which is 1,420 times more massive than our star and about 270,000 times brighter. But the most interesting part is that this extremely large red hypergiant isn't that far away, it's right in our Milky Way in the constellation Canis Major. If this star replaced our Sun, it would swallow up everything that lies even beyond Jupiter's orbit. VY Canis Majoris is so huge that when it explodes, its remnants will produce an incredibly massive black hole. It's really scary to imagine what will happen when Stephenson 2-18, the biggest star among all red supergiants, collapses. It's 2,150 times bigger than our Sun. Scientists have determined that this celestial body can fit a star the size of 10 billion suns. Moreover, its luminosity dramatically exceeds that of our star by 440,000 times. That means if it suddenly replaced our Sun, all the oceans and wildlife on Earth would be gone within moments. But it doesn't even need to be part of our solar system to destroy all living creatures on our planet. A massive explosion of Stephenson 2-18 and the subsequent emissions could damage the atmosphere of Earth even from a distance of 20,000 light-years. Among other things, it could destroy the ozone layer protecting us from harmful ultraviolet light. Yes, humans would survive, but most of the world's population would suffer from radiation-induced diseases. It's good to know that, unlike VY Canis Majoris, Stephenson 2-18 won't create a black hole after it dies. Otherwise, this hole would be absolutely enormous, and the number of other stars and planets it would devour is simply frightening. There are already lots of giant black holes in outer space. The biggest of them is called Phoenix A. Its estimated mass is 100 billion times the mass of our Sun. If you could move at the speed of light, you'd need 71 days and 14 hours to travel along its circumference. In comparison, during the same time and going at the same speed, you could circle Earth almost 462 million times along the equator. Furthermore, the bigger a black hole is, the stronger a gravitational field it has. This potentially puts all nearby objects in even more danger. Scientists, however, insist that we shouldn't worry this time because Phoenix A is quite far away. We can only hope they aren't wrong. But actually, they once believed that cosmic nebulae posed no threat either. Nebulae are giant clouds of dust and gas in interstellar space. When you Google the word space and find pretty colorful pictures, what you see in the majority of them is nebulae. They indeed look stunning, but you probably have no idea how enormous they are. For example, the diameter of the Tarantula Nebula reaches 1,862 light-years. In this video, I've repeatedly mentioned this unit of length, but do you realize the distance it implies? 1 light-year equals 9,460,732,472,000 meters. Now try to imagine an object a few thousand times bigger than this, equipped with long shining strings that look like spider legs. But there's an even larger nebula that contains as many as 15 trillion stars. So far, this is the hugest nebula known to science, NGC 262 Halo Cloud. It stretches over more than 1 million light-years, which is 537 times more than the area occupied by the Tarantula. Astronomers previously considered nebulae nothing more than mesmerizing space clusters, but it later became obvious that this beauty can also be dangerous. If a star or planet lies close to an active source of ejections that form a nebula, such as a young star or a supernova, they can receive a higher dose of radiation. In this case, the surfaces of neighboring celestial bodies can get damaged or even destroyed. Nobody knows how many space objects fell victim to NGC 262. Perhaps there were habitable worlds or, even worse, inhabited ones. Astronomers have Hubble, James Webb, and other super-powerful space telescopes, but none of them has helped them prove the existence of life on other planets. The main problem is that there are a lot more galaxies with amazing, extensive planetary systems than you could imagine. Modern science says that the number of galaxies in the universe exceeds 100 billion. Our Milky Way alone presumably harbors from several hundred billion to several trillion planets. The Milky Way is a colossal spiral, only 105,700 light-years in diameter. Right, it's much smaller than some of the nebulae, but despite this, it's quite big by the standards of galaxies. Just think about it, every single second, one new sun appears in the Milky Way. To fill an entire galaxy with stars, we'll need around 200 billion years, that is 14 times longer than our universe has existed. But nevertheless, our galaxy is nowhere close to its relatives. ESO 306-17 is a hypergiant elliptical galaxy, 1 million light-years in diameter. It's 9.5 times bigger than our Milky Way. Because of its powerful X-rays, ESO 306-17 is the brightest member of the Abell galaxy cluster, an accumulation of about 300 huge galaxies. Despite its impressive size, ESO 306-17 still isn't the absolute record holder. The biggest galaxy in the universe is IC 1101. Its diameter measures 6 million light-years. This galaxy is 50 times larger than our Milky Way and contains about 100 trillion stars. You must agree that such dimensions are hard to even imagine. To help you comprehend how gigantic IC 1101 is, let's put a light source on one of its edges and count how long it will take for the beam to reach the opposite side. Ready? So it will take 6 million years. It's not surprising that this space giant holds another record. It weighs about 100 trillion times more than our star, and it exceeds the Milky Way's mass by 200 trillion times. However, even this is nothing compared to the size of the visible universe. Scientists consider it to be a sphere with a radius of 46 billion light-years and a diameter of 92 billion light-years. This is the distance to the farthest objects of the universe that we can detect through modern telescopes. So I wonder how long it would take to get from one edge of the universe to the other. First, you must remember that the universe is expanding at a tremendous speed. In 1 second, it stretches over a distance of 73.3 kilometers, which means that with every passing minute, the universe becomes bigger by about 4,398 kilometers. But imagine we can freeze time and the universe suddenly stops expanding. You set off on your journey across the universe at the speed of light. It would take 46 billion years to get to the edge of the universe, and if you count the way back, you'd spend 92 billion years. Now imagine how big the universe will get in 92 billion years.